We are now in the second subtopic of chapter 3, which is binomial expansion. But before that, we introduce you to the expansion of a plus b to power of n. Using prior knowledge, we know what are the expansions of a plus b to the power of 0, to the power of 1, 2, or 3. But how about a plus b to the power of 5? By using a Pascal triangle, we will use number of coefficient at row 5 so that we will get a plus b to the power of 5. This is the expansion of it. However, it is also can be expanded by using the binomial expansion. Now, we look at n factorial. For any positive integer n, we define n factorial as n times n minus 1 times up till 1. So it means here we have to start with n according to our n factorial and ends with 1. We look at an example 5 factorial. So it is 5 times 4 times 3 up till 1 to get the answer 120. So now look at n plus 1 factorial. As previously, we have to start with n plus 1 and then multiply by the term minus 1 from the previous term, which is n minus 1 up till 1. We can also write this in the form of n plus 1 times n factorial. For example, we have 8 factorial. So it is equals to 8 times 7, 6, 5 up till 1. Take a look. 7 till 1 is actually 7 factorial. So we can write 8 factorial as 8 multiply 7 factorial. Next is the binomial coefficient. We can write in the form of this, which also means NCR, and the formula is equals to n factorials divided by n minus r factorial times r factorial. For example, we have 3c2. Again, 3c2 with n is 3 and r is 2. By substituting this n and r into the formula, we have the following. And simplifying it, we will get the answer 3. So now, we look at binomial expansion for positive integer n. So, for any positive integer n, we have the following expansion for a plus b to power of n. With a and b given, we start with nc0, a to power of n, b to power of 0. And doing so up till ncn, a to power 0, b to power n. We look at example 13, expand to x plus 1 to power 5 in ascending power of x. Hence, find the value of 1.02 to power 5 up to 4 significant figures. Notice that this is a, this is b, and this is n. So we can write a to x, b positive 1, and n 5. So now we need to substitute all these three values into our binomial expansion formula to get the following expansion. So 2x plus 1 to power of 5 is 5c0, 2x to power of 5, 1 to power 0, plus 5c1, 2x power 4, 1 to power 1, plus 5c2, 2x power 3, 1 power 2, plus 5c3, 2x power 2, 1 power 3, plus 5c4, 2x power 1, 1 power 4. And for the final term, 5c5, 2x power 0, and 1 power 5. Carefully calculate each term to get the following expansion. Notice that the question asks for ascending power of x. Our expansion is in descending power of x. x5, x4, x3, x2, x, and constant. So we need to rearrange the answer in ascending order of expansion. So now the correct answer will be 1 plus 10x plus 40x squared plus 80x cubed, okay, plus 80x to power 4 plus 32x to power 5. So now we have to find the value of 1.02 to power of 5 from our binomial expansion. To do so, we have to separate 1.02 into two terms as follows. 2 times 0.01 plus 1. Notice that we do this, okay, in order to compare with our previous binomial expansion, 2x plus 1. So from here, we know that the value of x is 0.01. With these values of x, we then must substitute into our binomials expansion that we found earlier to get the following expansion. Okay, so as you can see, every single x is replaced by 0.01. So by calculating it, we will get the value for 1.02 to power of 5 as 1.104, correct to 4 significant figures. And we are done. Next, we want to learn how to find a specific term for any binomial expansion a plus b to power of n. The r plus 1 term is given by t r plus 1 equals to NCR a to power n minus r, b to power of r. The suitable questions are to find rth term, term independent of x, and coefficient of x to power of n. We look at example 14. Find the r plus 1 term of binomial expansion x plus 1 over x to the power of 8. Hence, find the term independent of x and coefficient of x to the power of 4. From here, a is x and b is 1 over x. So we can write a x, b 1 over x, and n is 8. We will use this formula to find the r plus 1 term. So t r plus 1 is equals to 8cr. A is x, so x to the power of 8 minus r, and b is 1 over x to the power of r. We have to simplify 1 over x into x to the power of -1 in order to simplify the x. So after simplify, we will get 8cr, x to the power 8 minus r, and x to the power of -1 multiply r, so it is -r. We can put these two x together by adding the powers. Then we will get tr plus 1 equals to 8cr and x to the power of 8 minus 2r. So we are done with the r plus 1 term. Now for question A, the term independent of x means that we have x to the power of 0. And to do so, we equate 8 minus 2r with 0. So we have 8 minus 2r equals to 0. So we will get our r 4. Next, by substituting our r 4 into tr plus 1 formula, so we will get t 4 plus 1, that is 5, equals to 8c4 x to power of 0. Simplifying it, we will get t5 equals to 70, which means the term independent of x is 70. For question B, coefficient of x to power 4, we will equate 8 minus 2r with 4. So we will get 8 minus 2r equals to 4. Simplifying it, r is 2. Again, by substituting our r equals to 2 into tr plus 1 formula, we will get t3 equals to 8c2 x to power of 4. Simplifying it, so we will get t3 28 x to power of 4. So the conclusion is the coefficient of x to power 4 is 28. And we are done. Hi, we're still in the second subtopic for chapter 3. This time we have the binomial expansion for fraction or negative integer n. This is the formula for the expansion of 1 plus ax to power of n. Note that to use this expansion formula, we have to make sure we have 1 inside the bracket. and careful about its power n. It must be either fraction or negative integer n. Next, this expansion is valid for modulus ax less than 1. And we can write in the form between negative 1 over a and 1 over a. Hence, if we have a plus b to power of n, since there is no number 1 in our expression here, we then have to factor out a to get a times 1 plus b over a all together to power n. Next, we have to expand each to power n to get a to power n times 1 plus b over a to power n. Notice that we now have 1 in the bracket. So we can use the previous binomial expansion to expand this expression. And this binomial expansion is valid for modulus b over a less than 1. We look at example 15. Expand 1 plus 3x to power of 1 over 3 up to the term x cubed. And then determine the interval of x for which the expansion is valid. Hence, by substituting x equals to 1 over 1 to 5, determine the value of cube root of 2, correct to 4 decimal places. So first, if we compare this expression with the binomial expansion formula that we have here, so we know that n is 1 over 3 and ax is 3x. So by substituting these two values into the formula, we will get the expansion 1 plus 1 over 3 times 3x plus 1 over 3 times 1 over 3 minus 1 divided by 2 factorial and times 3x square. Next is 1 over 3, 1 over 3 minus 1, and another 1 over 3 minus 2 divided by 3 factorial and times 3x to power 3. And don't forget plus triple dots. Carefully calculate the coefficient of each term. We then get 1 plus x minus x squared plus 5 over 3 x cubed plus so on. And note that the last term in our expansion stops at x cubed because of the instruction expand up to the term x cubed. Next, for the validity, it is modulus less than 1 and it must be 3x. From here, we can write x is in between negative 1 over 3 and 1 over 3. So the expansion is valid for the values of x which is in between negative 1 over 3 and 1 over 3. Next, to find the value of cube root of 2, we need to substitute x 1 over 1 to 5 into both sides of the equation. At here, 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 and here. For the left hand side, we just need to simplify inside the bracket to get 128 over 125 to power of 1/3. And for the right hand side, carefully calculate to get 1.007937, and careful to give your answer at least in 5 decimal places or more. And note that we have to find the value of cube root of 2, but there is nowhere to be found in this left hand side. To do so, we have to write in the bracket here, in a multiple of numbers. So we can simplify 128 as a multiple of 2 and 64. Here is 125 to power of 1/3. So now cube root of 2 is 2. Cube root of 64 is 4. Divided by cube root of 125 is 5. So now we can see here cube root of 2 that we want to find. And to get this value, we have to multiply both sides, of the equation by 5/4. And then the answer will be 1.2599. Don't forget your answer must be correct to 4 decimal places. And we are done. Example 16. Determine the first 4 terms in the expansion of cube root of 1 plus x in ascending powers of x. State the range of x for which the expansion is valid. Hence, evaluate cube root of 8.08 correct to 4 significant figures. First, we have to expand cube root of 1 plus x, which can be written in the form of 1 plus x to power 1/3. And note that the power is a fraction and we have 1 in our bracket. So now we can simply use this formula to get 1 plus x to power 1/3 equals to 1 plus 1/3 times x plus 1/3 times 1/3 minus 1 divided by 2 factorial times x squared. And for the last term, 1/3, 1/3 minus 1, 1/3 minus 2, divided by 3 factorial and times x cubed. And don't forget plus triple dots. Don't forget to recheck our expansion with the instruction. Determine the first 4 terms. So 1, 2, 3, and 4 in ascending powers of x. X squared, x cubed. So it is correct. Carefully calculate for the expansion of right hand side. We then get 1 plus 1/3x minus 1/9x squared plus 5/81x cubed plus so on. For the validity, the expansion is valid for modulus x less than 1. So we can simplify into x in between -1 and 1. Now we have to evaluate cube root of 8.08, or we can write as 8.08 to power of 1 over 3. So in order to use our binomial expansion, we have to find the appropriate value of x to be substituted into our expansion. So, how to get our x? First step, we try to compare 8.08 here to the 1 plus x, since we have the same power 1 over 3. By doing so here is what I have, 1 plus x to power 1 over 3. So we will get x 7.08. Note that this value is out of range, so we cannot use x equal to 7.08 into our expansion. So now we try to do another method, which is we try to write 8.08 into two terms, which are 8 plus 0.08. Remember that to use our expansion formula, we must have 1 in our bracket, which we don't have here. To do so, we have to factor 8 out to have 8, big bracket, 1 plus 0.08 divided by 8, and then, here is supposedly my close bracket and power 1 over 3. Simplify it, we can get 2 times 1 plus 0.01 to power 1 over 3. Note that this one is similar to 1 plus x. So from here, we can conclude that x is 0.01, which is still within the validity range. So I suggest you to write this one as out of range, and for this one, within range. So for the last step, we will substitute value x equals to 0.01 into this expansion. So 8.08 to power of 1 over 3 can be simplified into 2 times 1 plus 0.01 to power 1 over 3. So it is equals to 2 times 1 plus 1 over 3. Don't forget, x will be substituted with 0.01. So here what we have, minus 1 over 9, 0.01 square plus 5 over 81, 0.01 cube. Simplify it, we will get the final answer for cube root of 8.08 is 2.007 in 4 significant figures. So we are done, and that's all for chapter 3.